Today we will be discussing objects that are falling and at the same time has a horizontal velocity. So first, try to imagine if the earth is flat and there is no gravity. Then if you throw an object, for example at 4 meters per second horizontally, every second, after 1 second, the velocity would still be 4 meters per second. After another second, the velocity would still be 4 meters per second. So even after many hours, it will maintain its velocity at 4 meters per second horizontally. Now imagine that we now have gravity. So if we have gravity, the object that was thrown will have a constant horizontal velocity like 4 meters constantly, but at the same time it will be falling down vertically at the rate of the acceleration due to gravity, which is 9.8 meters per second per second. Meaning, for example, if you have a object here, you throw it away like 10 meters per second to the right, it will be constantly going horizontally at a constant velocity of 10 meters per second. But at the same time, it will be falling at the rate of 9.8 meters per second per second. So for example, you have two stones. You have a stone here. You kicked it, and at the initial velocity of 10 meters per second horizontally, after 1 second, it will be at 10 meters. At the same time, the velocity at this point will be at 9.8 meters per second. Now, after 1 second, it will still have the same velocity, but the rate of descent will be bigger. So at this point, it will be around 19.6 meters per second at this point, the velocity. Then after 3 seconds, it will maintain the constant velocity of 10 meters per second, but the vertical one will be 3 times, because it's 3 seconds, 3 times 9.8 or 29.4 meters per second at this point. And then it will go faster, its descent will go faster, but the horizontal component will be the same. So example, after 4 seconds, it will be still at 10 meters per second horizontally, but vertically, the downward velocity will be 39.2 meters per second now at this point. And then after 5 seconds, it still be at 10 meters per second horizontally, but the velocity at this point vertically will be 49 meters per second. So it's dropping faster and faster. So if, for example, if you have two objects, if you release them at the same time, one of the object is just released from 0 downwards, and at the same time you release another object at 10 meters per second horizontally. One is going down, one is going this way, they will be reaching the ground at the same time. So regardless of the horizontal speed, they will reach the ground at exactly the same time. Example 1. A ball is kicked horizontally from a cliff at a speed of 8 meters per second. How far away from the cliff will it land if the height of the cliff is 1,960 meters? So let us first write down what are the given. So what are given? Now it has a horizontal velocity of 8 meters per second. So that's Vx going horizontally. Vx is 8 meters per second. Now the initial velocity on the y, on the vertical, initially will start at 0 because it was pushed only horizontally. There was no initial velocity downwards. So also what is given is the height of the cliff is 1,960 meters. Now we have to find the distance. We have to find the distance from here to here. Now, the formula from my previous video for the distance given the velocity and acceleration and time is d is equal to initial velocity times time plus 1/2 acceleration due to gravity times time squared. So we will need to first to compute the vertical this distance to see the number of seconds that it will fall from this point to this point. So as I said earlier, if you have two objects, one is dropped downwards, the other one is dropped with a horizontal velocity, they will reach the ground at the same time. So we can just compute first the vertical distance. So we can compute for the time that it will reach from here to here using this formula. So we can now plug in the values to get the time using the given values that we have. So we plugging the values. Now the distance is 1,960. The initial velocity on the vertical side is 0. So 0 times time, which we don't know, plus 1/2. So acceleration due to gravity is 9.8 meters per second or 9.8 meters per second squared times t squared, which we don't know. Now since the initial velocity is 0, so this will be 0. So just copy 1960. 1/2 times 9.8 is 4.9 meters per second squared times t squared. So we're looking for time, so we need to remove this. Oh, this is meters. So we always include the units for dimensional analysis, make it easier for us to see if we are correct in the units or not. So to remove this part, we divide it by 4.9 meters per second squared. So you also divide the other side by 4.9 meters per second squared. So this will cancel out. So what is left is t squared. So 1960 divided by 4.9 is approximately 400. Now the unit will be, if you divide the meters divided by meters per second squared, let's say we put a denominator 1, so that will be m over 1 divided by meters per second squared. So you get the reciprocal and make it multiplication, so this becomes m over 1 times second squared per meter. So this will cancel out. Your unit will be second squared. So to get, this is t squared, so to get t, we need to get the square root of both sides. So t squared becomes t. So the square root of 400 will be 20, and the square root of s squared is s. So time is 20 seconds. So now we have the time from here to here. Now we can compute for the distance, because we have the time that this one traveled from here to here. So we can have the distance because we have the horizontal velocity of 8 meters per second. So it's traveling constantly at 8 meters per second horizontally. So we can use this time to get the velocity. So velocity formula using the distance and time is this. So distance is velocity times time. So the distance will be the velocity, which is 8 meters per second, times time, which is 20 seconds. So seconds will cancel. So the distance is 8 times 20 is 160 meters. We will now reverse the question. A ball is kicked horizontally from a cliff at a speed of 8 meters per second. If it landed 160 meters away from the cliff, how high is the cliff? So let us first write all the given. So given, we have the horizontal velocity at 8 meters per second. Then we also have the distance at 160 meters. So acceleration due to gravity is 9.8 meters per second squared. Now the initial velocity vertically at this point is 0 because it was only pushed sideways. There's no downward velocity. So the initial velocity on the y-axis is 0. So what we need to find is the height of the cliff. Height of the cliff. Now the formula for the velocity, distance and time is this: velocity is distance over time. So we can plug in the values for the distance and the time and the velocity. So what happens is it has a horizontal velocity constant at 8 meters per second. So we can just compute the time that it traveled from here to here. Because it is a constant velocity and we have the distance, we can compute for the time. So velocity is constant at 8 meters per second horizontally. The distance is 160 meters and the time is unknown yet. So multiplying time on both sides to get the time on the numerator, we cancel out the time. So we have time is 8 meters per second is equal to 160 meters. So we want to isolate time, so we have to divide both sides by 8 meters per second. 8 meters per second divided by 8 meters per second. So this will cancel out. So time is equal to 160 divided by 8 is 20. So meters divided by meters per second, meters divided by meters per second, this is over 1, becomes meters times seconds over meters. This will cancel out. We have the unit seconds. So your time from here to here is 20 seconds, which is the same time as if it's going downwards vertically from here to here, is also the same time. So we can use this time to compute for the height of the cliff using the acceleration due to gravity, free fall. So the formula for that is d is equal to the initial velocity vertically times time is equal to times plus 1/2 gt squared. Now the distance, we don't know yet. Initial velocity, as we have said, is 0, so this will be 0. 1/2. G is at 9.8 meters per second squared times t squared, so t is 20 seconds. 20 seconds, the quantity squared. 1/2 times 9.8 is 4.9 meters per second squared. 20 times 20 is 400. Seconds times seconds is second squared. So we can cancel second squared. 4.9 times 400 is 1,960 meters. So this is the height of the cliff.